told like limitation of propositional logic. Like if you get this type of sentence, all the girls are intelligent or some apples are sweet. Listen, if in between if you don't get anything, then it can. So in that case, and if we are being asked to represent this propositional logic in a truth table, we can't do it. Okay, because because no doubt this is a propositional logic, but here all is mentioned. Okay, so for to overcome this type of situation, we have postural logic. Uh,
ମ୍ୟାମ୍ ଭଏସ୍ ଟିକେ ଲୋ ଆସୁଛି।
Now.
ୟେସ୍ ମ୍ୟାମ୍।
Okay. So in first order logic, it is another way. There you can, wherever you will find the word like all, not, from, at least, there you can use your first order logic. Okay. It is another way of your knowledge representation. It is also called as your predicate logic or first order predicate logic. Okay, so there objects will, we have to identify what is the relation between the object, that you have to identify. Okay, constants will be there, variables will be there. Predicate means the relationship, whether the relationship between two objects, brother relation, father relation, less than, greater than, that is nothing but your predicate. Okay, one thing I want to clear in first order logic, just you have to identify only two things: what is the subject, what is the predicate. Predicate, as you know that in a sentence, in a English sentence, excluding that subject part, whatever you have, that all comes under predicate. From that predicate you have to identify the relation. Okay, and accordingly you have to construct a first order logic. Okay, these are the connectors: logical and, logical not, your negation operator, implication, double implication. This is equality. Here one thing is, in case of your first order logic, only difference is we have to, here two things are have been added, that is your quantifier. This symbol is your universal quantifier, this symbol is your existential quantifier. Universal quantifier will be applied in the case wherever we will find the word all. Okay, everyone. If we find this type of word in a sentence, then we have to use universal quantifier. And if we find any word like at least, somebody, someone, some, or in that type of sentence, in that type of word, we have to use existential quantifier. Okay, then here this is the syntax. This is a syntax to find a, to construct a predicate logic. Listen, here we have atomic sentence. Like in case of a propositional logic, also I have told you atomic sentence, that is constructing one, say, propositional logic. In atomic sentence means this can be constructed using one first order logic. Complex sentence means combination of more than one atomic sentence. Okay, so the structure of the predicate logic or first order logic is, first of all you have to write the what is the predicate, what is the relationship, within bracket what are the terms, what are the these terms are your object. Okay, suppose I will say, for example, Robbie and Ajay are brothers. Okay, so Robbie and Ajay is your subject, and predicate is whatever you have after verb, that is your predicate. No, so brothers, that the relationship between them is brother. So brother is my predicate. Within bracket you have to write Robbie, comma Ajay. That indicates that Robbie and Ajay are brother. Getting? Yes or
ma'am.
no? Suppose I will say Chinky is a cat. Chinky is your subject. Whatever we have after verb, that is our predicate. So cat is the relationship. So predicate you have to write within bracket. You have to write Chinky. That identifies that Chinky is a cat. Okay, so complex sentence, same. In complex sentence also, combination of more than one atomic sentence, that is your complex sentence. There also you have to find what is subject, what is predicate. Okay, suppose I will say, I have told you this quantifiers just few times before, that two types of quantifiers are used: universal quantifier, existential quantifier. Listen, to construct the first order logic, these things are needed. Okay, construct constantive need, variables, predicate, function, connectives, equality, quantifier. That doesn't mean that in all the cases this all these things will be needed, but depending upon the situation, you will need these things only. Okay. So, as I told, in universal quantifier, if you get the word like for all, everyone, everything, in that case, you will use this universal quantifier. And if you find for some at least one, then in that case, you have to use existential quantifier. This is the symbol for universal quantifier. Okay. In another one thing I want to tell you, in universal quantifier, you have to use this. This is the symbol, but you have to use this implication symbol. I will tell. I will take one example, and with that example, I will say how this happens. Okay, you have to use in always remember in case of your universal quantifier, you have to use this implication symbol, and in case of your existential quantifier, you have to use and operator. Okay, in universal sim quantifier, you have to use this implication operator, and in that case, you have to use and operator. Suppose I will say if x is a variable, then this symbol x will be read as for all x. Somebody may read it as for each x, somebody may read it as for every x. Okay, suppose for example, I this type of question you will get in your exam. You will be given all men drink coffee. You have to represent it in first order logic or predicate logic or first order predicate logic. Okay. All men drink coffee. Listen, all men drink coffee means x1 can be a man, x2 can be a man, x3, x4, x5, xn. Those can be a man. Okay. So whatever the question you will get, if you find all or some, that indicates that this is not a simple propositional logic. It is your first order logic. Okay, here you have to write the first order logic, and here presence of this all indicates that you have to use universal quantifier. Universal quantifier means its symbol is for all, this symbol. Okay, always whenever you are using, you may use either universal quantifier or existential quantifier. Always a variable must be attached with that symbol. Okay, so I will read it as for all x, but question is all man. That means what? For all x, if x is a man, for if x is a man, for that your symbol will be man is your predicate within bracket x, that indicates man is x, that means sorry, x is your man. Okay, for all x, if x is a man, then what? All men drink coffee, then x can drink coffee. No. So for that, then for that symbol is implication symbol will be used. Then here the predicate is drink, so drink you have to write who drink coffee, x drink coffee. No, because we have declared x for man within bracket x comma coffee. Okay, for all x, if x is a man, because question is all man drink coffee. Okay, we can't write x drink coffee. Who is x? For that again we have to declare that x is a man. So for that, for all x, x is a man. Okay, so if x is a man means in that case man is our predicate. So man within bracket x, implication symbol, that means what? If x is a man, then x drink coffee. Then in that case predicate is our drink within bracket x comma coffee. Getting? Any doubt?
Ma'am, here two predicates are connected by this implication symbol.
Yes, the in universal quantifier or existential quantifier, two predicate can be connected. Two predicate can be connected using this operator. Two or more predicate can be connected. I will go with rest of the examples.
Okay, ma'am.
But this example you got, no?
Yes, ma'am.
Okay. In case of your existential quantifier, this is the symbol of existential quantifier. I have told you in existential quantifier we use this AND operator or conjunction symbol. Okay, in existential quantifier you may read it as there exist or for some for at least one x. Okay, suppose question is some boys are intelligent. You have to represent it using first order logic. Okay, some boys are intelligent. So presence of the some indicates that you have to use first of all existential quantifier. Okay, same like universal quantifier, just you have to use first this symbol, there exist symbol, there exist always, that may be universal, that may be existential, always a variable should be attached. So there exist, then x. Who is x? X should be a boy. Some boys are intelligent, so boys is a predicate, boys within bracket x. If x is a boy, then what? Boys are intelligent, no? Some boys are intelligent. So in this case, we have to use this logical AND operator. In that case, we were given giving what implication symbol. So here you use logical AND operator. Then intelligent, here intelligent is our predicate. Intelligent within bracket x. Okay, there there exists some boy or some boy. There exists x. If x is boy, then they are intelligent. Okay, in that case we are given implication symbol, but in this case we have to use logical AND operator. This is the difference only. Okay.
Yes, ma'am.
So there are some properties of quantifiers that is universal, that may be universal or that may be existential quantifier. So in universal quantifier, if I will you write like for all x for all y, it is similar to for all y for all x. Okay. In existential quantifier, if there is written somewhere there exists x, there exists y, it is also similar to there exists y, there exists x. But if this combination of, if you get anywhere the combination of universal and existential, like there exists x and for all y, that is not similar to for all y there exists x. Okay, I will tell how it happens. Listen, these are some examples, some of your first order logic using quantifier. This type of question you will get. Suppose, listen, this, let me solve, let me explain one example, and you just, I will share this note and you look at all those examples that I have given, you can get it. Okay, suppose I will tell you have to construct a first order logic for not all students like both mathematics and science. Okay, not all students like mathematics, both mathematics and science. So for that, what will happen? First of all, not is there, that means for, from this you can identify that you have to use negation operator, logical not operator. Okay, excluding this, you have question all students like both mathematics and science. So in this case, whatever the question will be given, you have to first identify which quantifier you have to will be used there, and what is the predicate in that question. Okay, so in this case, presence of this all identifies that, determines that you have to use universal quantifier. Okay, and here our predicate is like. Like means, suppose within bracket you have to write one object comma another object. No, suppose I will write x comma y. So x is a student and y is the subject. And how many subject we have? Two subject. That means mathematics and science. That means what? We have to write like x comma mathematics. That means x likes mathematics, and operator x comma science. That means x likes mathematics and x likes science. Okay, so coming to the first order logic, first of all, for not, you have not operator, logical not operator, then for all you have to use universal quantifier, this symbol. With that, one variable will be attached. Who is x? X is a student. So within bracket you have to write student within bracket x. That as here universal quantifier is used, implication symbol will be used. If x is a student, then x likes mathematics and x likes science. So like, listen here, it is written like x mathematics, and logical, and like x science. You within a bracket you may write x comma mathematics and x comma science. Both are correct. Getting?
Ma'am means like then bracket रे x तापरे
Bracket,
mathematics
हाँ.
तापरे mathematics पुणी x पुणी science.
ना मैथमेटिक्स पर एंड ऑपरेटर तापर एक्स कमा साइंस.
मैम सेठी जो and operator टा लागला सेटा existential quantifier की.
ना ना सेटा एक्जिस्टेंशियल क्वांटिफायर नाही. एठी मैथमेटिक्स एंड साइंस अछि ना, एंड आइडेंटिफाइज योर एंड ऑपरेटर. जदि और थांता और ऑपरेटर लागि थांता. एठी तमरो जो इम्प्लिकेशन सिंबल अछि तमने ए तमे एक्जिस्टेंशियल क्वांटिफायर हेतिले इम्प्लिकेशन सिंबल जगह रे तमे एंड ऑपरेटर लगे थांता. इफ x is a student, after that you use and operator in case of your existential quantifier. If x is a student, you use implication operator if it is an universal quantifier. बुझिपाल? एठी लगेबो
Yes ma'am.
तमे. या पर डिपेंड करे तमरो क्वेश्चन ऊपर. क्वेश्चन रे कोन अछि? एठी मोर एंड अछि, सेति पे मु एठी एंड लगेती. हला?
Yes ma'am.
Okay, so all these questions you may solve it by your own. Solution is also given. Okay, next to your propositional first order logic, you have planning in your syllabus. Nothing is there in planning. Actually, what happens normal in your day-to-day life, to do any task you have to do a planning. Okay, so in AI what happens, the one you have you heard regarding Tower of Hanoi? Tower of Hanoi, have you heard anybody? Anybody? Tower of Hanoi, have you heard? Answer me. You know or don't know?
No.
Okay. So in this, that is one of the example of planning. Okay. In case of your planning, you have to, that means what is your plan to construct a thing to reach to your goal state? What is your plan? Listen, here I have done like this. Suppose this is one block. In this where only B is present. This is another block where A and C are present. This is your start state, but your goal state is first of all, your goal state is in another. This is one stack. In this is a stack. This is a stack. This is a stack. Okay. So in this stack, only one element is there, B, and that is the top element. In this stack, two elements are there, A and C, and A is present at the topmost page position.
मैम आपण स्क्रीन प्रेजेंट करछथि कि?
हाँ.
मैम हमु मैम दिसुनी.
Okay, wait. Now visible?
Yes ma'am.
Okay. So in this stack, you have one element, that is a single element. So that is the topmost element. In this stack, you have two elements, so A and C. So in A is your topmost element, but these are your starting state. But your goal state is the A should be present at the topmost position. B is next to A, then C is should be the bottom position. That means what is the planning? What is your planning? Okay, what is your planning to construct this to reach to your goal state? What is your planning? So first of all, what you will do? First, you remove this A, what should be your planning? You have to write in a step by step manner. Step 1, you can remove this A to another position. Okay, you can remove A to another position, or you can remove A to top of the B, isn't it? Anybody can do in your way. This will vary from person to person. This type of example will be given, and you will be given to, you have to construct this way what should be your planning. Okay, in this example, suppose I will remove A. Always you can remove the topmost element, you can't remove this C. Okay, if you want to remove this C, then first of all you have to remove A, then C will be remained. Okay, suppose on the above on a top to A, suppose another one element is there and you want to remove C. First of all you have to remove that top element, then then it's after removing that top element, A is the topmost element, you have to remove this A, then only you can do anything with C. Okay, so as my goal state is this one, I have to construct this. What should be my planning? You have to write stepwise. Step 1, I will remove this topmost element, remove topmost element A as the top of B. Okay, B. After that C is there, then you can immediately no, yes, either to B or top to B, or you can remove anywhere that will be your single element. Then upon C, B will be there, you put B, then upon your B you just put A as the top element. Getting that is your Tower
Yes,
of
ma'am.
Hanoi. Here I have taken only 3 example, but there you will be given either B, C, A. Accordingly, you will do it. Here I have done it very easily. Okay, starting goal state will be there, starting state will be there. You just do some arrangement so that you will reach to your goal state. That is the thing. Okay, so after that you have probabilistic reasoning in artificial intelligence. Just wait. Is it visible?
Yes, ma'am.
Okay. So what happens in case of your probability? Listen, when probability comes into picture, when probability comes into picture, when we have not certain knowledge, when we are uncertain about a knowledge, in that case probability comes into picture. Suppose I will say in a class 85% of students scores no math scores good in mathematics, and 15% of students, suppose 65% of students score good in mathematics, 35% of students score good in history, and anything. Okay, and I will be asked like what is the probability that how many percentage of students scores good in mathematics or history. Okay, and when we are not certain about a knowledge, in that case probability comes into feature. Okay, we have seen first order logic, propositional logic. Okay, where predicates were being used. In that case, we were known about the knowledge. Those are the types of knowledge representation. But in this case, in case of your probability, if we are not certain about a knowledge, in that case probability will be used. Okay, suppose this happens, uncertainty happens due to experimental error, temperature variation, climate change. Okay, so in case of your probability, what is the need of your probability is when there are unpredictable outcome, when specification or possibilities or predicates become too large, Okay, when possibility is too large, when an unknown error occurs during an experiment. Suppose an error occurs during experiment. Suppose it's always probability. It will always vary from 0 to 1. That we know. Okay. Suppose its probability is 0.85. Then the probability that with the experiment with that error will not come, the result will be 1 minus 0.85. 0.15 will be the result, isn't it?
Yes, ma'am.
Okay. So in probabilistic reasoning, there are two ways to solve problem. One is your bias rule, another one is your Bayesian statistics. This bias rule is very, very important. So in case of your probability, what are the properties of probability? Always probability of a variable will always lie in between 0 to 1. Okay, this A is, we call this A is an event. Okay, probability of A if equals to 0, that indicates the total uncertainty in an event, and if it is 1, that indicates total certainty of an event. And we calculate the probability of an uncertain event. Always probability is meant for uncertain event, and if we minus that from 1, then we will get the certainty event. Okay, probability of any types of occurrence, we calculate it as number of desired outcome divided by total number of outcome. And always remember that as we are saying that it will vary from 0 to 1, and total of this probability should be 1. So probability of not A plus probability of A definitely equals to 1. Okay, so in this case, and here this A is our event. Event means each possible outcome of a variable. Okay, each possible outcome of a variable, that is an event. Sample space means total collection of all possible event. That is our sample space. And random variables are used to represent the events and objects in the real world. I will tell. Listen, another this you may get this things in your Azure short question. You also took concept here. We have to discuss prior probability, posterior probability. Prior probability of an event is the probability computed before observing the new information. That I will tell how we have to calculate this prior probability. And posterior probability is calculated. Listen, after conducting the before conducting the experiment, whatever we had, so that was our prior probability. And after calculating all evidence or information, and this posterior probability is your combination of prior probability and new information, if you get the new information only. Okay, in case of your conditional this question you will get from I may get as 5 marks question from conditional probability. Suppose you want to calculate that the event A when event B has already occurred. Okay, event you want to calculate where event B has already occurred, that will be written as probability of A this slash or B. Okay, that indicate probability of A where event B has already occurred. That its formula is probability of A and B divided by probability of B. This probability of A and B, we call it as joint probability of A and B. Listen, its proof is there. I will send you. No need for your in your syllabus, for you people, its proof is not required. If anybody wants, then I can send it. Okay, so probability of A and B is your joint probability, and probability of B we call it as marginal probability of B. Okay, here we have we have the formula for probability of event A where B has already occurred. If I want to I want to calculate the probability of B event B where A has already occurred. In that case, just whatever has already occurred in denominator, that its probability will be there. Probability of B or A equals to probability of A and B divided by probability of A. Okay, and if the question is will be given, listen, question will be given in this way, like probability of A and B is something, and probability of A will be given, and you will be asked what is the probability of B where A has already occurred. Then just put the formula. Okay, or if this is the or question may be asked like probability of B with A is given, and this person is given and this person is given, you are being asked to find this one. You just multiply this with this, then you will get this one, probability of A and B. Okay, this is the thing, A and B. This is A, sorry, yes, A and B intersection part. Okay, I will tell. Listen, in a class, there are 70% of the students who like English. That means what? For English, if you take probability of and 40% of students who like English and mathematics. Okay, let this this is a this is probability of B. B is an event that a student likes English. So probability of B will be what? 70% means 0.7, and 40% of students who likes English and mathematics. If A is a event that students like mathematics and English. So in that case, probability of A and B is will be, yes, A is students who like mathematics. So probability of A and B will be what? 0.4, as 40% is there. Question is, what is the percent of students those who like English also like mathematics? That who like English also like mathematics. That means probability of A. That means how many percent of students likes mathematics, where that, and those students already likes English also. Okay, so you have to find probability of A or B. Formula is given, that is 50, just you have to divide it, you will get 57% of students who like English also like mathematics. Okay. Next, coming to your Bayes theorem. In this is the Bayes theorem. In case of your Bayes reasoning, yes, probability, as I was saying, probability of A or A and B, you can multiply it. Okay, it may be given whatever from this example, whatever will be given, according to your question, you may, if this is given and this is just, you just use this formula. If this is given and this is just, you just cross it. Okay, this is the formula, that is your Bayes theorem. Here two probability, two events are given, that's why we are using this formula. In case of your more than one, in case of your more than one event will be given, this will be the formula, probability of A of I where B is already occurred. Listen, this will not come in your exam. This you will be given only two variable or two event, and with that you have to use the Bayes theorem. This if we are saying probability of cause or effect, this is A where effect has already occurred. Okay, effect has already occurred. This is one formula. In that case, in this can be one formula also, where probability of B, probability of event B where A is already occurred into probability of A divided by probability of B. Whatever you can write. In all the cases, you will get the same answer. Okay, what is the probability that patient has diseases? This type of question we have discussed. This type of question we have discussed. You may find it. Okay. Listen, another way of representing your Bayesian network is your Bayesian belief network. As we know that network means that must be the combination of your some nodes and some that means one relationship between node to node must be there, that indicates some node is parent of another node. Okay, network Bayesian network is a probabilistic graphical model that represents a set of variables and their conditional dependencies using a directed acyclic graph. Okay, acyclic graph means with that graph no cycle must be formed. Okay, it is also called as decision network. In your syllabus, it is given decision tree. Okay, that is the thing. Bayes network, it is a tree-like structure. That's why we call it as decision tree. Probability distribution we have to use. You may is you have to write these three things, these points. Also, you have to write its application. If the question is being asked in your exam, its application are your prediction, anomaly detection, diagnostic, automated insight. That means what in case of your suppose in case of your diagnosis of one disease, okay, disease late somebody suffers from heart stroke, mild heart stroke. Okay, for that you have to do you only that means does doctor only prescribe to do what the only ECG echo for mild heart stroke? No, no. For that, again another all the parameters we have to do. Okay, that means this Bayesian network of parameters we have to test. For example, like we have to find what is the cholesterol level, what is blood pressure, what is the thyroid. All the things are interrelated with each other. To do a diagnostic, a doctor should know regarding all these things. Okay, so. So in this case, Bayesian network, that means you can't predict anything. Okay, so that is the Bayesian network. Okay, that can be done with the help of directed acyclic graph or table of conditional probabilities. That I will say how table of conditional probability you will find a Bayesian network graph is made up of nodes and arcs. These are your nodes A, B, C, D is your nodes. As I have told you that acyclic graph is formed. Acyclic means no cycle. Look at here. This looks like cycle, but no cycle. A to D, D to C. If again A will go from C to B, B to A, that would be a cycle. But here A to D, D to C, again A to B, B to C. Okay, that is not the cycle. Okay, you may do it like that means this is one graph, this is another graph. Okay, so if always Bayesian network is always your acyclic graph. Okay, acyclic graph, or we call it as directed acyclic graph. Wait, one question. Let me discuss. Yes. The question is calculate the probability that alarm has sounded, but there is neither a burglary nor an earthquake occurred. Look at this question. Again, I'm saying calculate the probability that alarm has sounded, but there is neither a burglary nor an earthquake occurred, and David and Sophia both called the Harry. Okay, this David and Sophia both called the Harry. This is given only to confuse you. Just you have to concentrate on. This is given to confuse you, but they have a role to solve the problem. D S A B E. D is for David calls. S I have written in this order. You may write in any order. Okay. D S A B E. Okay. Then what we know, probability of D, probability you have to find the result of this one first. Okay, probability of DSABE equals to probability of D shows that SABE has already occurred. probability of D with SA, that means we have to find probability of D W. What is the probability of D? So that this Sophia calls and alarm occurred. Okay, so probability, what is the probability? Probability of D shows that SABE occurred. That will be listen, this comes from that formula, Bayesian calculation that we have done. Bayesian calculation that we have done. Probability of, this is probability of A and B. Probability of A and B is what? Probability of A on the probability of A shows that B is already occurred into probability of B. Probability of B, in this case B is our SABE. So probability of SABE. Again we have, listen, we have to we have to solve again this one. Okay, we know that from this step probability of D with SABE is already occurred. Again we have to find the solution of probability of SABE, that is probability of A and B. So probability of A and B is probability of A shows that B is already occurred, that is probability of A shows that ABE is already occurred into probability of B. Probability of B is your ABE. Again we are given these two things and we have to find probability of ABE. Same probability of A and B. Probability of A, this will be probability of A shows that BE is already occurred into probability of BE. After that it will be probability of B shows that E is already occurred. Okay, E is already occurred into probability of E. Okay, so just wait. Yes, for SBE here we have calculated. Yes, this is the thing. After this, after doing this, you have to do one network. You have to construct one acyclic graph like this with alarm. Main objective is to ring this alarm. Okay, alarm to sound this alarm. Okay, alarm is there. So question is what? Question is, the alarm was sounded, but there is neither a burglary nor an earthquake occurred. Okay, nor an earthquake occurred. So there is one. If so, for this what alarm is the alarm. If alarm sounded, David calls and Sophia calls. So alarm is the parent. And during this alarm, neither burglary occurred, neither earthquake occurred. So one arrow comes from burglary and one arrow comes from earthquake, and but from alarm, arrow comes to David calls, arrow comes to Sophia calls, because when alarm is called, at that time David calls and Sophia calls. This example, this truth table is nothing but your probability, conditional probability table. Okay, that indicates what? Suppose one truth table, what is the truth? What is the truthness of your alarm is sounded? Okay, suppose B and E is given. Okay, B, in case of your B and E, what should be your truth table? In two variable, your truth table will contain four outcomes, 2 to the power 2. That baby with true, 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 false, false, true, false, false. Okay, suppose probability of A is true, that is alarm is sounded. If it is true, and this value we have taken at our own only. Okay, probability of A equals to true. If I will take is whereas B and E are true, that means burglary is occurred, earthquake is occurred, and if alarm is sounded, and if we give it as 0.94, then alarm is not sounded. For that your result will be 0.06, because we will minus from 1. Okay, in case of your true and false, it is occurred and it is not occurred. In that case, if alarm is sounded and if its probability is 0.95, it should be 0.05. Okay, by mistake I have written here, it should be 0.05. And No, it is given, I think. Yes. 0.8, it is given 0.04, 0.69, 0.69. Okay, it is given 0.69, 0.69. It is the thing in case this will be given. This will also be given if false value is alarm is sounded, like in this case, in case of your alarm, the result may be your true and false. And what is the condition? What is the probability that your D will call David calls that is true and David calls that is false. If this is 0.91, this value will be 0.9. If this is 0.05, this value will be 0.95. Here also some mistakes is there. Oh, you have to always minus from 1. You have to do this type of calculation. Okay, because this example I have taken from my previous note. Anyway, so after that, whatever we have done this, I have written here only. Then, but it will be, but in your question it is given that probability of S, your S is what? Probability of S is, what is the what probability of S is, that means what is the probability of Sophia calls? Okay, so this is the probability of where the probability of S is true. 0.75. Listen, here I have taken 0.75. You may take it as 0.85 or 0.95. No problem. Because in your question it is not given that its probability. So you may take it by your own. What is the probability if S is occurred or S is false? So 0.75 into probability of D shows that A is already occurred. Probability of D such that A is already occurred, that is 0.91. This is 0.91 into probability of D, probability of D such that A is already occurred, because what D is for who is D? David calls where alarm is occurred, so probably we have to go for probability of D. Yes, 0.91. Probability of probability of A we have calculated for SD. Yes, probability of A shows that negation of B, and this one and this. Why I have given negation of B and negation of E? Because it is in your question, it is mentioned that neither a burglary nor an earthquake. That's why we have mentioned here negation of B comma negation of E. Okay, so its value is negation of B and negation of E. If wait, negation of B comma negation of E. Yes, negation of B means, hello, hello. Am I
Yes, ma'am.
audible or?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so probability of A, what is your probability of A shows that negation of B and negation of E. Probability of A, its probability yes. Probability of A shows that negation of B and negation of E. In that case, where you have negation of B, this case and negation, yes, only this case, 0.01 or not. Where you have negation of B, in this case negation of B, and in this case negation of B. What was the probability? 0.001. So you have to multiply with 0.001 into probability of negation of B. Negation of B. Probability, এটা কোন, এটা কোଉଠୁ ଆସୁଛି probability? এই case ରେ କଣ ହେଲା? Probability of A shows that A is already occurred, that means Sophia calls alarm sounds ଯେତେବେଳେ sound କରୁଛି. এই case ରେ probability of D, that means David calls where alarm is already sound, but in this case probability of ଆମର question କଣ କହୁଛି? Neither burglary nor earthquake occurred, no? So here I have to calculate like probability of A alarm shows that negation of B and negation of E. So you have to go for this table. This table will be given. So negation of B, negation of E कोठी आसुची. Negation of B माने B value false थिबो. Negation of E माने E value false थिबो. At that time what was the alarm value? So negation of B एटा ए के सिर्फ alarm value केते आसुची 0.001. So 0.001. Okay. बुझेला.
Yes, ma'am.
अच्छा. The probability next one is your into probability of negation of B. Probability of B first of all what is the probability of B? Probability of B where probability of B is true. Probability of B where probability of B is true 0.002. Yes, probability of B. This one is the probability. It देइसे ना burglary पे এটা given আছে. This is given for earthquake. So probability of B is true 0.002. And sorry probability of negation of B ना negation of B यदि probability of B यदि 0.002 negation of B कौन होगा 0.998 probability of negation of E this is given probability for earthquake true value is 0.001 but question is negation of F so 0.999 ହେଲା if table गुड़ाक given थिबो you will be asked to find the ଏଇ ଭଳିଆ question ଗୋଟେ ଥିବ ହେଲା ଏଇ ଭଳିଆ question ଗୋଟେ ଥିବ ଏଇ question ରୁ ତମକୁ ଏଇଟା identify କରିବାର ଅଛି probability of S D A negation of B negation of E and you have to write the formula and you have to just put these values from this conditional table and just multiply it that much and you have to draw this network getting just either true value given thile false value बाहर करि परिबो कि नहीं अरे yes or no
Yes, ma'am.
Yes, ma'am.
okay so that is the thing okay with this probability uncertainty knowledge from Bayes theorem is completed again tomorrow you I have told you no to tell me regarding your class after completion of a lab of your section
Ma'am,
B student
ମ୍ୟାମ୍ କାଲିର ତ ସିଓର ନାହିଁ ଅବିକା ଆମର କ୍ଲାସ ହବନି ଗୋଟାଏ
नहीं ଏବେ ମୋର କ୍ଲାସ୍ ଅଛି
ଓକେ ମ୍ୟାମ୍
ତମେ କାଲି ନହେଲେ ମତେ ସେକେଣ୍ଡ ହାଫ ନାଇଁ 12:30 ରେ କୁହ 12:30 ରେ ମୁଁ ହାର୍ଡଲି ହାଫ ଆନ୍ ଆୱାର ନେବି ଏଟା ସିଓର ନାହିଁ କାହିଁକି ତମର ଲ୍ୟାବ ସରିଲା ପରେ କହିବ ଲ୍ୟାବ ତମର
ଓକେ
କଣ
ମ୍ୟାମ୍
12:30 ଯାଏଁ ହଉଛି
ୟେସ୍ ମ୍ୟାମ୍
12 ହେଲା ମୁଁ ହାଫ ଆନ୍ ଆୱାର କ୍ଲାସ୍ ନେବି ଠିକ ଅଛି
ଓକେ ମ୍ୟାମ୍ ୟେସ୍ ମ୍ୟାମ୍
ଓକେ ଥ୍ୟାଙ୍କ ୟୁ
ଥ୍ୟାଙ୍କ ୟୁ ମ୍ୟାମ୍
Thank you, ma'am.
Thank you.